Okay, so let's start in here. If we have a trigonometric function, how to solve this question? Okay, so in here, for the trigonometric function sine and cosine, the domain it will be r, which is from minus infinity to infinity. Okay, what about finding the first derivative directly? So since in here there is no horizontal or vertical asymptotes, so I'll start directly with the f prime. So the derivative of sine, this is equal to cosine x. The derivative of cosine is minus sine. Minus with minus, it will be positive sine x. So let's make this equal to 0 and move the cosine to this side. So sine x is equal to minus cosine. Then divide by cosine and divide by cosine. So that will give you tan x equal to minus 1. Now, after that, we can find in here tan inverse of minus 1. So x, it will be tan inverse of minus 1. Okay, so this is equal to minus pi over 4 plus, since we have tan x, that means we have plus n pi. If we have sine x or cosine x, that means you have to add 2n pi. Okay, that depends on the period all the time. So whatever. So this is minus pi over 4 plus n pi. So in here, I'll start with the number line test. So directly I'll start with minus pi over 4. Since this is periodic function, so this critical number, it will be repeated after n pi. So minus pi over 4 plus 1 pi, for example, this is equal to 3 pi over 4 plus 1 pi, which is equal to 7 pi over 4, and etc. Okay, so in here we have the angle, this angle, which is 45 in negative. Okay, this is 135, and this is 315 in degrees, if you would like to calculate in degrees. So to calculate this, just you have to multiply, okay, the angle, which is 7 pi over 4, for example, by 180 over by, it will give you the angle in radians, or sorry, in degrees. Okay, so whatever. So let's continue. So let's substitute to just find the values or the signs of the function along this interval. So in here, if we have okay, so in degrees or radians, so let's put, for example, in degrees if I would like to calculate it in degrees. So this is sine alpha alpha x. Just put the derivative. This is my derivative, sine x plus cosine x. Sine x plus cosine x, cosine alpha x. Okay, close the parentheses, substitute any value. So calc at less than minus 45. Let's take minus 50, for example. Okay, then put equal. This is negative. Okay, so the first one is negative between minus 45 and 135. So calculate at 100, let's say. This is positive. Then calculate between 130, so negative, positive, between 135 and 315. Let's calculate at 200. It is negative, and after 315, let's calculate at 320. 320. So it's negative, positive, negative, positive all the time. Okay, so in here we have negative, positive, negative, positive. So down, up, down, up. So in here, I can write in here, for example, if I would like to write the local minimum points. So in here, local minimum at minus by over 4. Okay. Now, because this is repeated, the minimum is repeated every 2 n by, because in here, minus by over 4, it was minimum, then it will be maximum, then minimum again, then maximum, then minimum, etc. So plus 2n by, the minimum, it will be repeated, and for local max, it will be 3 by over 4 plus 2n by. Okay. So that's it. That's it. So this is for the max, minimum, etc. Okay, so critical numbers. Critical numbers, we have minus pi over 4, 3 pi over 4. So critical numbers all the time, it will be minus pi over 4. That's it. Minus pi over 4 plus n by. Okay, so directly, let's go ahead and find the second derivative. So that's it. Okay, so second derivative. So this is equal to what? The cosine, the derivative cosine is minus sine x. The derivative of sine is equal to cosine plus cosine x. Let's make this equal to 0. Move the sine to this side. So that's it. Okay, so moving the sine, so that will give me cosine x equal to sine x, then divide by cosine x, divide by cosine x, then that will give you 1 equal to tan x. Okay, then x, it will be equal to tan inverse of 1. Now, once you calculate this, if you would like, you can find it directly using your calculator if you don't know the answer. So you can convert your calculator, shift menu, then angle input, it will be in radian. Okay, then you will choose shift tan inverse of 1, close the parentheses, and go ahead. So this is pi over 4. So in here, this is pi over 4. So x is equal to pi over 4. Since I have tan x, then I will add in pi. So directly I'll start with graphing the number line. So that's it. Okay, okay. So I have pi over 4. Then I will add pi. Pi over 4 plus pi, which is plus 4 pi over 4, which is equal to 5 pi over 4, plus pi, which is equal to 9 pi over 4. If I continue, I will not be finished. Okay, so until the end. Okay, there is no end actually, because in here this is a periodic function. Okay, whatever. So let's substitute the values, okay, to know just the signs. So in here, let's say if we have, okay, so my function is what? My function is, okay, the second derivative. Okay, so let's, before doing that, let's convert these angles to be in degrees. I prefer actually calculating this in degrees. So pi over 4, this is 45 degrees. 5 pi over 4, which is 5 pi over 4 multiplied by 180 over pi, which is equal to 225, 5, and 9 pi over 4. Okay, this is equal to 405. Okay, so in here, let's calculate the value. Okay, so shift menu, angle unit, degrees. So angle less than 45, I'll substitute it in cosine x. So it will be cosine x. Okay. minus sine x. Okay, that's good. So that's it. This is my second derivative. So calc less than 45. So I will take it as 40. So this is positive. Then let's take a value between 45 and 225. So let's take 200 for example. Calc at 200. So this is negative. Then calc, so positive, negative, then calc at 300 between 225. Okay, that's it, which is positive. So positive, negative, positive. Okay, so this is positive, negative, positive, and I think in here 405. So calc at 410. This is negative. Okay, so in here this is negative, positive, negative, positive. So this is concave up, this is concave down, this is concave up, this is concave down. Okay, so in here we can see that concavity, it will be endless actually, because this is a periodic function. So it will be repeated all the time. Then the next interval after concave down, it will be concave up, then concave down, then concave up, etc. So in here I can write inflection point. So inflection point, it will be pi over 4 plus n pi. Okay, so we can substitute this any value. Okay, pi over 4, for example, you can substitute in the function to find the inflection point. So directly you can find the value. You can find the inflection point, the next inflection point, which is at 5 pi over 4. You can substitute it in the function and find the value of that. So as you like. Okay, so in here we can start by finding the graph. So let's go ahead and find the graph for this function. So I will take this. That's it.